Hi, students. In this next video, we're going to continue our discussion with molar volume at STP, but we're going to apply it to gas stoichiometry. So we've already discussed stoichiometry in previous chapters and discussions. In this particular video, we're going to focus on, well, what if a reaction has a gas and the gas is under standard temperature and pressure conditions? Can we employ stoichiometry? So we see gases are produced in many chemical reactions, and we can set these chemical reactions under standard temperature and pressure conditions to help us theoretically calculate what volumes would be produced. So we can use the mole ratios or the mole factors from the balanced equations to help us do this. And remember, that was the centerpiece of our stoichiometry calculations, is the mole ratios in a balanced chemical equation. So gases can either be products or reactants, and they're involved in these stoichiometric problems. But the only way to use that conversion factor is to make sure that the conditions are under STP. Again, I like to say instead of 0 degrees Celsius, 273 Kelvin, because when we deal with gases, we're always using the absolute temperature scale of Kelvin. So here's an example. What volume in liters of O2 gas is needed to completely react with 15 grams of aluminum at STP? So how do I recognize that this is a stoichiometric problem? First, they give me a quantity of one of my reactants. They want to know a quantity for a different reactant. Now, in the past, we dealt with solids pretty consistently, so we were always given grams, and we could easily convert grams to moles using molar mass, and then use our mole ratios in our balanced equation. In this case, when we're looking for the desired unit, instead of going to grams, they want liters. But the nice thing is, because this is a gas and it's at STP, I can use 1 mole of any gas is 22.4 liters. So I have the first condition for stoichiometry, a balanced chemical equation. I can then convert my grams of aluminum to moles of aluminum using molar mass. I can convert my moles of aluminum to moles of oxygen using my mole ratio in my balanced chemical equation. And lastly, using molar volume that we derive from Avogadro's law, I can convert moles of O2 easily to liters using molar volume at STP. So here's the calculation. 15 grams of aluminum. I use its molar mass, convert grams to moles of aluminum. Moles of aluminum to moles of O2. I use my 4 to 3 mole ratio from my balanced chemical equation, and now my units for moles of aluminum cancel. And then my 3 moles of O2, I can easily convert to liters using my molar volume at STP. 1 mole of any gas occupies 22.4 liters. And I get 9.33 liters of O2 at STP. Can we go the other way? Can you be given liters of a gas and then figure out grams of something else? If it's at STP, I'm writing 1 mole, doesn't matter the gas, 22.4 liters. So I want grams of water. I'm given liters of H2. I have a balanced chemical equation. I can go from liters of H2 to moles of H2. And I can go from moles of H2 to moles of water using my mole ratio and then get to grams using molar mass. So there you have it. 1.24 liters at STP. I can use molar volume, and 1 liter or 22.4 liters is 1 mole. I use my mole ratio, 2 moles of H2, 2 moles of water, and then I use my molar mass. 1 mole of water gives me 18.02 grams, and I'm left with the number of grams of water that are produced. So again, stoichiometry, but now we're just applying a new ratio. So instead of molar mass grams per mole, or instead of Avogadro's number, 1 mole is 6.022 times 10 to the 23rd particles, now we're using molar volume, which allows us to change the volume of a gas to moles, because you're not going to weigh out you're not going to weigh out the grams of a gas. It's impractical. It's easier to measure out the volume. So what mass of iron will react with 5.50 liters of O2? And again, the magic STP, liters to moles of O2, moles of O2 to moles of iron, and then using molar mass, grams of iron. Oh, I didn't show the work. So I'll write that out for you. Sorry about that. 5.50 liters. There's 22.4 liters of O2 per mole of O2 gas. And then my mole ratio, 3 moles of O2, whoops, 3 moles of O2 per 4 moles of iron. Where am I getting that? My mole ratio. And 1 mole of iron. Just like you, I got to grab my periodic table. Is, because I don't memorize this, so 1 mole of iron is 55.85 grams of iron. And when I calculate that all out, I should get that beautiful number right there. So I hope this video helps you understand how useful molar volume is at STP in our stoichiometric calculations, that we have gas, reactants, and products in our reactions. Thanks so much for watching.